This last section of the classwork is the most difficult. I'm going to try to graphically show you what we're doing, but basically there will be times where you have to find two different z-scores. There'll be times where you have to find one z-score and understand how to double it. Basically, when it says differs from the population by more than or less than a certain percentage, I have to kind of consider graphically what's going on. So here we're told that 75% of the advertisements for a children's TV show are for children's toys. That's going to be our population P. P equals 0.75. We're going to look at 110 advertisements. That's going to be our N. N equals 110. Otherwise, we're not told a specific P hat to look at. Instead, what we're told is we're trying to find the probability that it differs from the population by less than 1%. So graphically, here's what we're doing. If we think about the graph that's centered at 0.75, moving 1% is moving 0.01 in either direction. 0.01 this way would be 0.74. 0.01 this way would be 0.76. If it differs by less than 1%, that means that it's within this shaded area here. Differing by less than is really a between question. Between question using 0.76 as p hat once, using 0.74 as p hat the second time, running the formula twice, using the table twice, and then taking larger p-value minus smaller. So let's see how the formula would set up. First time, I'm going to use this 0.74 as my p hat. I'm going to subtract the population value, 0.75, put it over the root of the population value, 0.75, times 1 minus that 0.75, all over the n of 110. I'm also going to find a z-score for 0.76. It's going to be over the same root, 0.75, 1 minus 0.75, over 110. So when I go to my calculator, I put in the first one, parentheses, 0.74 minus 0.75, divided by the root of parentheses, 0.75, 1 minus 0.75, divided by 110. And I get that z-score to be negative. That z-score is negative 0.24. If I know that the table is symmetric and I understand how that works, I can jump right to saying this z-score has to be positive 0.24. I can double check it by putting it in my calculator, typing in the same thing but using 0.76 instead of 0.74, and I will verify that these have to be equal and opposite. So since we moved the same distance to the left and to the right, these have to be identical z-scores, this one negative, this one positive. I now need to look up each of the two z-scores in my table. When I look at the negative side, negative 0.24 gives me 0.4052. When I look on the positive side, positive 0.24 gives me 0.5948. Again, since it's a between question, I'm subtracting larger minus smaller. So I'm doing 0.5948 minus 0.4052. When I put that in my calculator, 0.5948 minus 0.4052, it gives me the correct final answer of 0.1896. Looking at the bottom problem here, it's the same general idea with one key difference. At the end, it says differs by over 4% instead of less than 1% like it was before. So I'm still going to pull out the key information. It says 86% take advantage of financing, so P equals 0.86. Tells me we're going to be looking at 230 recent sales, so N equals 230. Then it says by over 4%. So I again need to consider graphically what over 4% means. If we're centered at 86%, 0.86, moving 4% this way would would get me to 0.82. Moving 4% this way would get me to 0.90. Instead of shading the area in between, I'm going to shade the area outside. Over 4% means further away. So really I want this tail area and I want this tail area. The good news is, because of the symmetric nature of the table, this area and this area must be exactly equal. So if all I do is find this area to the left of 0.82 and double it, I won't need to do a second z-score for 0.90. So when it differs by over 4%, I can focus on the left side when it differs by more than and just double it. When it differs by less than, I need to find both z-scores and use them to find the area in between. So I'm going to set up my z-score for the left side here based on 0.82 minus 0.86. It's going to be over the root of 0.86 times 1 minus 0.86 divided by that n of 230. When I put this in my calculator, parentheses 0.82 minus 0.86 and parentheses divided by the root of parentheses 0.86 times parentheses 1 minus 0.86, all divided by 230, making sure it's still all done under the root. I get a z-score of z equals negative 1. In my calculator it's 748, so I'm going to call it negative 1.75. Again, I go to my table, making sure I'm on the negative side. Negative 1.75 gets me to the p-value of 0.0401. Again, at this point, I could do the same setup for a z-score for 0.90, find the table value, do 1 minus that table value, but if I did all those steps, I would get right back to 0.0401, because these must be exactly equal. So instead of going through all that and doing the z-score for 0.90, I'm just going to double the score I got on this side. If I do 2 times 0.0401, I get 0.0802, which is the correct final answer for this last problem.